In this video, we talk about the main topic of the course, which is computational geometry. We're going to have a quick introduction to this area. So computational geometry is essentially an area that deals with algorithms that deal with geometric data. So any sort of algorithmic solution that you have where the input has some sort of geometric property or has some geometric interpretation, then you could consider that part of computational geometry. And geometric data could mean, let's say, points, lines, circles, hyperplanes, higher dimensional objects, and things like that. There are lots of applications of computational geometry. In particular, I guess there are obvious places you encounter them, such as graphics. For example, if you think about any 3D game, there is, of course, data that has geometric interpretations, such as points and lines and surfaces and stuff like that. It also holds in geometric information systems, such as Google Maps, where you need to find shortest path in the terrain or things like that. Robotics could involve computational geometry. For example, if you have a robot that wants to find its path through a terrain, that has geometric interpretation. But more interestingly, there are also areas with abstract data types that can be interpreted as geometric data. Databases is one example, where if we have a database of, let's say, users, and if each user has a bunch of numerical values, then that user can be interpreted as a point. The classic example is that you have an employee, you have a database of employees, and each employee has an age attribute, which is numerical, as well as salary, which is numerical. Then the pair age of employee I and the salary of employee I could be interpreted as the x and y coordinates of a point. So therefore, an employee can be represented as a point in two-dimensional space. Let's look at one example of a problem in computational geometry to see what we're talking about. So this is a very simple example. Imagine you have a file that has n lines where the ith line contains two numbers, xi and yi. And these two numbers are interpreted as the xi and the yi coordinate of a point pi. So every line describes one point with those two numbers. So we want to read this file, and then given four values, L, R, B, and T, we want to find all the points that lie inside the rectangle with the left boundary L, the right boundary R, the top boundary T, and the bottom boundary B. We want to solve this problem. If you want, try to pause this video to think about this for a minute. Okay, so I hope you have paused the video to think about this. Now I'm going to give you the solution, which is probably not too surprising. It's relatively easy. First thing you do is that you somehow read your data. So you read xi and yi's in some sort of data structure, such as arrays or something. It doesn't really matter. And then we run a for loop. In the ith iteration of the for loop, we check the coordinates of the ith point. If the xi coordinate of the ith point is between L and R, and the y coordinate is between B and T, then we can say that that point is inside the rectangle, so therefore we output it. So the interesting part of this program is this part, right, which is the logic of the program. Where does this logic comes from? This logic comes from our geometric interpretation of what it means for a point to be inside a rectangle. We say that a point xi, yi is inside a rectangle if both of its x coordinates lie inside the boundaries of the rectangle as well as the y coordinates. So this is something we obtain by looking at the geometry of the problem. If you just give this source code to someone, it is probably difficult for them to figure out what does this program represent. In other words, by just looking at this abstract program, we can't really get this geometric interpretation. And that's actually one of the crucial things about computational geometry. To understand where the computational geometry algorithms come from, you need to have some sort of geometric understanding of how these geometric topics relate to each other. What are the properties of points, lines, rectangles, and things like that. The main logic of this program essentially comes from the main property of points and rectangles. And we're going to see lots of examples like this later on.